test is next class. So, ladies and gentlemen, the first thing that they're asking is how do the graphs y equals cosine of theta and y equals 2 cosine of theta compare? Now, unless you are in pre-calculus or you're in took a trigonometry class, this might be something that you would have no idea about. All right? But again, let's kind of think about some of the things that we would understand about the problem that we might be able to figure out the answer. Because obviously, there's going to be problems you're going to have no idea what to do. And what do? We underline the important information, right? We underline, we try to restate the question. And then we try to look at things that we know, all right? So that's what I'm going to try to do, pretending that nobody has taken pre-calculus in this class. Now, how do the graphs y equals 2 cosine of theta and y equals 2 cosine of theta compare? So what I'm going to do is I'm going to compare, I'm going to bring in two problems that maybe you guys might be a little bit more familiar with. Maybe let's look at 2 times the absolute value of x and y equals 2 times x squared. You should be familiar with this because in Algebra 2, we did discuss what are about the transformations and the graphs of the absolute value function as well as the quadratic. Or, the quadratic function. So when we look at this, we need to kind of represent, well, what did that 2 do to the graph? What did it shift the graph left or right? Did it change anything? Or did it kind of stretch or compress the graph? And it was my ladder, the stretch or the compress, right? The 2, what that did was horizontally compress the graph. So it looked like it was a much skinnier V or parabola, right? Do you guys kind of remember? And then also remember if this was negative, that reflected it over the x-axis and so forth. So we know that something in this graph, whatever the cosine graph looks like, FYI, the cosine graph does, at least the initial period of the cosine graph does look like this. Okay, we're not going to get into the x scale, but that's actually what the graph would look like. All right, and this is actually a continuous graph, continues in the negative and the positive direction. But it's really irregardless of what exactly the graph looks like that we can think this through. Now, so it says how do they compare? And we have a lot of things. We have twice the period, the same amplitude, half the period, the same amplitude, twice the period, half the amplitude, same period, twice the amplitude, same period. So let's look at this. From going from here to here, what is the only thing that's changing? 2, right? So instead of having a 1, which you could recognize here, we now have a 2. So from going from this new graph, we could say that at least something is being doubled, right? Or at least has twice the value. OK? So what I would look into, so we're comparing the graph, so we can see that there's something twice as much. So Jennifer, when I'm looking at that, I could have twice the period, right, and the same amplitude. That could be an option F. Half the period and the same amplitude, that wouldn't kind of make sense. So I'm going to cross off G. Twice the period and half the amplitude. Again, twice makes sense, but having half of something just initially doesn't really make sense because I'm not really seeing why I would have anything would be the half. Sheldon, can you take the backpack off the desk, please? So I'm going to cross out H. I'm going to cross off J because, again, that's half the amplitude. And then I have, again, K, which says twice the amplitude and the same period. So both of those kind of look, about the same. And what they represent is either twice the period, the same amplitude, or twice the amplitude, same period. Those are the 2 that would make sense to me because I know something is being doubled, right? I don't see anything that would really make sense half if go to here to here. Now, it could be possible. But initially, without knowing anything, I wouldn't suspect any of that. So with thinking about this, I either need to determine, well, what's happening? Am I going to get the amplitude, or am I going to be getting the period? All right? And if you guys think about this, like when we have the regular graph, here's quadratic, and then I multiply it by 2, all I'm doing is really kind of compressing this graph. All right? And what happens is the compression, the amplitude, just think about amplitude and period. Period kind of represents, all right, let me think about it this way. So if I was going to kind of compress this graph, maybe my graph would look something like this, which actually is the correct version of that. OK? So if my amplitude is 2, that means it would go up to 2 and now go down to -2. So it looks something like this. All right? But what happens is period is something that's cyclical, right? Something that's going to happen over and over. And so this period, the amount of distance that it takes for the graph to repeat itself is not actually going to change. All this outside is doing is compressing, or actually it's actually elongating this graph, but the distances and everything the same. So if you guys want to write this down, a little FYI, the absolute value of A is what we call the amplitude. All right? So by multiplying this by 2, it's going to kind of have the same effect as it did on these other functions. And it's just going to affect the amplitude, which is going to be kind of the the height, the max and the mins of the graph. It's not going to affect anything with its cycle, which we would think about with period. So I would make my estimated guess just on understanding what amplitude and period represent. I would go with amplitude. But the actual true answer is, again, amplitude, as absolute value equals amplitude. I'm not going to go through how to find the period unless we start getting into some more trigonometric functions.